Okay, I'm going to walk you through the problem-solving process for a Newton-second law problem. So we've got a problem in the corner. We've got a 10-kilogram crate. It's lifted to the top of a cliff with a rope. If the upwards acceleration of this crate is 2 meters per second squared, we want to know the tension in this rope. All right, so the first thing you have to do is establish some directions. So I'm going to choose up as positive and down as negative. There is no motion in the x direction. If there was, I would need to choose that as well, but there isn't. So I'm just going to put this over to the side here. Okay, just to be super clear about what's going on. Okay, the first thing you need to do is draw a free body diagram. So I've got a box, or it's a crate, I guess. That's a dot. It's 10 kilograms, so I'm going to label that with its mass. And I don't really need axes, but you can put them in if you want to. I might as well. Okay, where up is positive, down is negative, left is negative, right is positive. Remember, those are choices that I've made. You could choose anything you want, frankly. Okay. Okay. And I need the forces acting on this crate. So, do those in a different color, I think. I guess we'll just use black. Okay. So, this crate, well, if we're on Earth, gravity is pulling down. So that's definitely there. I'm going to put it in there. The force of gravity. For this crate, that would be m times g, which this crate is 10 kilograms. And g is 9.8 meters per second squared. So the force of gravity has a magnitude of 98 newtons. Okay, pulling down. I have a checklist in my head about which forces to might be existing. So there's always gravity. Does gravity exist in this situation? Probably, but think about it. Does it? Then put it on the diagram. Other things to check. Is there anything touching this box? All right, crate. Well, a rope. Okay, if something is touching, that's a contact force, or the possibility of a contact force. So there is a force from this rope. If I'm lifting it upwards, that probably means I'm looking at a situation like this. It's like a rope. Here's the crate. It wouldn't hurt to make a little diagram like this, not a free body diagram, to see where the rope is. And the tension always lies right along the rope. Okay, so there is a force pulling up because that's where the rope is. I don't know how much that is. I'm just going to call it T for tension. And that's actually what I'm going to try and find. What is the tension in this rope? But I don't know it yet, so just draw it and label it. Okay. That's it for this. This is a very simple problem. Just two little forces. They're in the same dimension and everything, which is really nice. Okay. This was step one. Draw a free body diagram. That's it. Just get it done. Okay. The next step. Step 2, I guess. Next step is you're going to write Newton's second law. Okay? Probably in component form. That is, instead of just straight up writing vector F net equals A or M times vector A, we're going to write F net in the x direction equals mass times acceleration in the x direction, and F net in the y direction equals mass times acceleration in the y direction. Now for this problem, we only need the second one. So I'm going to write that where I've got some more room. Okay, I'm going to write that down. You should write it down first before trying to plug anything in. Just write it down. Okay, just write it down. Just symbols. All right. Then on the left-hand side, you're going to write in the net force in the y direction. Literally just write down the forces. So in this diagram, I've got two forces in the y direction. I've got T. It's pointing toward the positive side, so that's going to be a positive T. Okay? And I've got 98 newtons. It's pointing toward the negative side, so I'm going to have plus negative 98 or just minus 98 is fine. Okay? write that out. Like, don't try to take shortcuts here. Just write down all the forces in the y direction. If I had 3 forces, I'd have 3 terms. Just write the whole thing out. That takes the place of F net y on the left-hand side of the equation. On the right-hand side, if you know mass, fill it in, and I do. Okay. If you know acceleration, fill it in, and I do. Now we have to be a little careful here. It says the acceleration right here. It says the acceleration of this box is 2 meters per second squared. It also says this is an upwards acceleration. I have chosen up to be positive, so my acceleration is positive 2. Please be careful. That could be something different on other problems. All right, the acceleration could be something else. It could be a different sign. Be aware of this. This is something you need to be careful about. Okay? If you get that sign wrong, it's going to mess everything up. All right. If I had the x direction, I'd do that too, but I don't, so I'm just kind of stuck. And eventually what you're going to end up with is a system of equations and unknowns. Now, this is a system of one equation and one unknown. That's nice. Okay? So this is my system right here, and I need to solve it for t. So if I solve this for t, I'm gonna get 20. Move that over there. It's plus 98. So tension will be. It's really late. It's almost 10 p.m. for me. That's late for someone in their late 30s. Let's see, that'd be 118 newtons is the tension in the rope. Last thing you do is just do a mental check on this, okay? The way that we've set this up, where we have put the signs into the net force on the left-hand side, whenever we solve for a force, we should get a magnitude of that force when we do this, which means I should always get a positive number if I'm talking about a force. There's no vector signs anywhere. It's all just T's and F's because I'm just doing components. Check on the magnitude. Does this make sense? Like, this rope is basically doing 2 jobs. It's just holding up against gravity, but it's also making this thing accelerate upwards. So I should have a force that's bigger than what I would need just to counteract gravity. So that makes sense. Now that's about all you can really check. Just does it make sense? Okay. So again, process. Draw a free body diagram with directions. Establish your coordinate system. Write Newton's second law in component form for x and y. Fill it in. Well, I guess that'd be the third one. Fill it in. Fill in what you know. Fill in what you can. Solve the system. I can't make my pinky go down all the way. It's there. Solve the system of equations that results. And that's it. That's what you do.